data structures using C, implementation of a queue using array data type. My dear friends, in this lecture, you will learn, first of all, the algorithm to implement a queue. You know, queue is a ADT, abstract data type. There are two important operations in that: to insert an item into the queue and to delete an item into the queue. So then we will learn how to implement the queue using array data type. Later we will do it using linked list data type. So these are the two operations. So Enqueue and DQueue. Enqueue to insert item into the queue and DQueue to remove data item from the queue. So we are going to write these two functions. Of course, we are going to write two more functions, but these are two very important functions associated with the queue data structure. Then at the end, what we will do is we will combine all these and we will write a menu driven program in C to show the working of a queue. First of all, queue. You're very familiar. You go to any, earlier we used to go to movies and we had to stay in the queue there and buy the ticket. We couldn't jump the queue and people would shout. Similarly, go to a bank. So you are a teller there and each one is given a token, and according to the token number, you go and get your money or deposit your amount, money. Then here we have got a queue of cars. The first car will have to go first, second car followed by that. So that is the whole thing. That is queue. So first in, first out is the theme or the slogan which goes along with the queue. Of course, here, when it comes to human persons, in cars, you know, they bypass and they overtake, but that is not allowed unless it is a priority queue. Then I give priority to some others who may have come later, but they may be allowed to go earlier. So these are some examples, day-to-day examples in our life we use to form this concept of queue, abstract data type called queue, and use it in our computer programs. Now, what is a queue? In data structures, an ordered list where insertions occur at the rear, at the end, insertions occur at the end, and deletions occur in front. And this is how our regular queues go on in our day-to-day lives. So additions at the end, back of the queue or the rear of the queue, and deletions take place at the front of the queue. Therefore, it is known as FIFO, first in, first out. The first person, first item, first goes out. So this is the how it is defined. FIFO for queue. For stacks, you know, it is LIFO. So last in, first out. Here, first in, first out for queues. So we'll take some, these are the real world examples of the queue. Now we come to this. So this is a queue with some data items here. This is the front of the queue. This is the back of the queue. As I said, Enqueue, addition of items, inserting of items takes place at the back or the rear of the queue. And deletion of items here, I delete it, comes here. Then I delete the next one. That will be done at the front of the queue. So this is how our queue works. And we shall see how to implement this queue. Now, for example, one animation to explain the working of the queue. So we'll get into what is called the Enqueue, inserting data item into a linear queue. So I've got an array here with 5, or the most I can insert 5 numbers. The size is 5 for this, and it is 0 to 4. So size is 5. So what do? I want to insert the numbers. Now at the beginning, therefore, front and the rear will be pointing to 0 when I start inserting. First thing is, really what we do is we start rear as -1. When we want to insert, I increment the value of rear to 0. And front will always remain, in our case, always remains at 0. So now rear and front are pointing to the first location. So I want to input, therefore. While inputting, first thing I need to ask is, whether this queue is full. If that means if there are 5 items here, I cannot insert more item. So therefore I ask, therefore if rear, index of rear here, it is going to be 4, therefore 5 minus 1. If the index of rear is equal to 4, I say print queue is full. That is very important. That is what we are going to implement in our. Whereas if the rear is minus 1, because I said when the queue is empty, I am going to assign minus 1 to rear. So then we know that uh, this queue is empty. So let us see now. Now both of them are pointing. Rear is pointing to the first index, first location. So I'm inserting 70 into that. Now I want to insert second number. First what I do is I increment the rear value. It becomes 1. Then I insert 30 at A1. Then again, I want to insert one more number. I increment the value of rear to 2 and then add 60 to that. So A2 is equal to 60. Now what I do is again, I want to insert one more number. As you see, it is done at the rear of this queue. So again, I am inserting 80. Now let us see, now we would like to delete. So now I am deleting 70. Therefore, now what do I do? Of course, one thing is I can increment the value of front to 1. Then if I delete 60, I can increment it to. But it is not a good way of doing, because in one case, the front and rear will be pointing to 80, and then you will say the queue is full. Queue is full. It is not true. So therefore, I suggest that once you have deleted the first number, we copy 30 to 0, then 60 to 1, 80 to 2, and decrement the value of rear to 2. So that is how we are going to do in our way of implementing this queue. And when it comes, will be later circular queue, there is no problem. There is continues to be add or remove numbers. So this is how we are going to do insert items into a queue. So as I said, decremented here. So now we come to the algorithm for Enqueue. So first I check whether the queue is full. Therefore, if rear is equal to size minus 1, then I say queue is full. I come out of this. Otherwise, I increment the value of rear and then add this number to queue rear value. So for example, here we'll consider this example. At the moment rear is pointing to 3. I want to insert one more number. So what do? It is not full, therefore I increment the value of rear to 4. And then I insert this number 70. So this is how I insert numbers. As I said, always at the rear. Suppose I want to insert one more number. I'm not doing it here. So what I have to increment the value of rear and then insert the number. And suppose I want to insert one more. And see, in this case, the size is 6. 6 minus 1 is 5. Therefore, immediately this message will be typed there. The queue is full, you cannot insert number. Then you have to delete one number and then insert some other number. So this is algorithm for Enqueue. What we will do is we will write C program immediately. Why don't you write now, pause this video for some time and write make a C function called Enqueue, which returns number. So it int Enqueue and int number. So you convert this algorithm into C code. With that, we go to the next DQ. First, we will check in this algorithm whether the queue is empty. When is queue empty? When rear is equal to minus 1, queue is empty, and then I come out of that. This is not necessary. Rear equal to 0. So then otherwise what do? I get the number from the front and put it, get that number. And then now I copy from 0 to n rear minus 1. I copy all the, as you see, q plus 1. Q1 is copied to Q0, then Q2 is copied to Q1. I go on like that till I come to rear minus 1. So this way queue is always, the front will always have a number. So I will be only removing the first number from my queue. Then I have to decrement the value of queue because we have deleted one number. Therefore, rear value is going to be one less than the earlier. So this is DQ algorithm for DQ. Now again, pause this video for some time and write the corresponding C program or function, make a function in C. And in this case, as you see, int, because it is returning a number. That's all. There is nothing to be passed here. It is only going to delete number. So now the third function is to print queue. I want to print the values of the queue starting from the first 0 to rear, 0 to rear. So we go on printing. So 0, 10, 20, 50, etc. It is going to print the values of a present in the queue. So now we come to the implementation in C program. So first thing is you create a data type, new data structure called queue, which contains a queue, an array queue of the size here in 5 I have given, and then front two indices here, front and rear. Front will always be 0 and rear is going to be, to begin with, it is going to have -1 value, then you go on incrementing. So these are the 5 functions we have written here. Enqueue to enter number, insert number, DQ to remove the first number, and print queue is to print the content of the queue. Menu is to, because this is a menu driven program we are writing, so menu is there, and then we init queue. I want to init queue. When you do that function, I'm going to initialize front is equal to 0 and rear is equal to -1. So that is what we are going to do. Here is the menu, complete menu driven program, the main. So I've got choice, etc. Init queue, I am going to init queue, call this very important. You have to initialize the queue before you start any operations. So here we have case 1, case 2, case 3, case 4, case 5. So for example, here this is the menu. The first is enter a number, 2 delete a number from the queue, 3 display the content of the queue, 4 is exit, etc. Enter your choice. And as you see, this menu function, you are going to get choice. It has to be a pointer variable because you are accepting the choice here and passing it as the parameter in the menu function. So we are using therefore the menu function, get the value for choice, and then to get into the loop I have given choice as 1, but you call that function again, then you enter 1 automatically. It will come here, case 1, enter a number, it scans that number and enters that number into the queue. If it is 2, delete, you are using this function delete queue, dq, and get the number, print that number, and of course get ch is important. Then you, case 3 is print queue, you just call that function print queue and get ch break, and if it is 4, exit, and default it should go always to menu. So if you enter a wrong number, it has to go back to menu. So that is the thing. So here we have got this function enqueue. I'm very sure you have written this enqueue. First to check whether the queue is full, and if it is not so, then you increment the value of rear, you add, of course I've given here, this helps you to debug your program, it's not necessary after that. So then you insert that number. Here DQ, first to check whether the queue is empty. If it is empty, you give that message, you return. And otherwise what you do is you remove that number from the front and put it in number. You get that number, then you copy every or next number to the previous location, and then afterwards to decrement the value of rear and return number. So you have got init queue here, init queue. So front is 0, rear is equal to -1. This is the print queue you are very familiar with. So here we have some examples. So for example, I have entered here 3 times, and then I said display content of the queue. So it has displayed the content of the queue here, as you see, 30, 37, 50. Then again I am entering 80. So then it is giving enter 80, is giving me the index here. Front is 0, rear is 4, and I pressed 3. As you see here it was, then I have entered 70 and then 80 here. So now the whole queue is full. Now let us so I want to enter, I say enter choice 1, I want to enter 70, but then it is says queue is full, cannot insert a number. So then what I do is I want to delete a number. So I am deleting here. So deleted number is 30 and I display again 3 and immediately it prints 50, 37, 50, 70, 80. The first number here 30 has been deleted. So this is how your menu driven program has to work. So I request all of you to spend a lot of time and then try to work out. You may get stuck. Very important to get stuck. You will learn so much when you get stuck and complete this menu driven program to implement to show the working of a queue using array data type. Thank you.